Since the wave function depends only on r, we can choose our volume elements to be shells of radius r, thickness dr, and volume dv, which means that the integral over all space of Ch41S r squared dv can be written as the integral from 0 to infinity of 1 over pi a cubed e to the minus 2 r over a times 4 pi r squared dr. So this is what dv would be. This is the psi squared. And if we do this simplification, we can get 4 over a cubed integral from 0 to infinity of r squared e to the minus 2r over a dr. And looking this up in a table or doing a calculation on a computer, we find out that this is 4 over a cubed times minus ar squared over 2 minus a squared r over 2 minus a cubed over 4 all times e to the minus 2r over a between 0 and infinity. At r equals 0, the last term in the parentheses, this term here is good. This is 0, this is 0, and this is just e to the 0, which is 1. For infinity, we get e to the minus infinity, which is 0. So this becomes 4 over a cubed times a cubed over 4, which is 1. And that means that it is normalized. And because we want the condition for normalization is that the integral from all space equals 1. For part B, to find the probability, we say P equals from 0 to a of Ch41S squared times 4 pi r squared dr. So this equals, as we've seen, 4 over a cubed times, if we look at this equation and put a in it, we will get minus 5a cubed e to the minus 2 over 4, and when we put 0 in there, we get minus a cubed over 4, so it turns into a positive. And this equals minus 5 e to the minus 2 plus 1, which is about 0.323.